Okay, hi again. We're continuing with the second lecture for this week on the environment, chapter 5 in the Wright textbook. And the second half of the chapter is devoted to the problem of global warming. And this is clearly the biggest environmental problem faced by the United States, communities throughout the United States, and the world. We can define global warming as an increase in carbon dioxide in the atmosphere created by human activity. And that's the key thing, human activity. A fancy word for saying this is anthropogenic climate change. And this is important because in some of the debate, especially among those who are casting doubt that global warming is actually taking place, uh, do look at non-human sources of uh, carbon emissions. And so the global warming, again, just emphasizing human activity, what humans do. So we'll come back to that. One important point that I wanted to highlight is that 50% or more of the gases that cause climate change, and this is referred to as greenhouse gases, the primary one is carbon dioxide, and this comes from the burning of fossil fuels. So that's the overwhelming source of greenhouse gases. There are others, and some of these are from non-human activity, chlorofluorocarbons, methane, ozone, and nitrous oxide. Those are also important greenhouse gases. So the way it works, and I don't necessarily feel like I'm an expert on this, is that basically heat comes down to the Earth's surface, and some of this heat, as the normal process, is reflected back into the atmosphere. Um, and the problem is that this natural process whereby heat is reflected back into the atmosphere, some of it becomes trapped as a result of carbon dioxide and other gases that are in the atmosphere. And this results in the Earth warming. So these gases, they get caught, they get trapped in the atmosphere. They can't escape further up, and they become concentrated and serve as kind of somewhat of a shield, so to speak, that prevents the excess heat from reflecting off of the Earth and back into the atmosphere. And so this overall kind of creates a warming. It's a similar kind of thing, or to make an analogy, think of how when you step into a automobile, into your car on a hot day, it's been warming all day because the sun's energy passes through the car's windshield and gets kind of trapped inside. And so I'm sure I've experienced this all summer where it's just really hot in the car when you get in there in the afternoon. So it's a similar kind of idea here, working on a global scale. Now, some of the evidence that uh, shows that global warming is taking place is the increased concentration of CO2 in the atmosphere. This graph here shows the increase in CO2 from 1870 to 2000. And in 1870, there was something like 290 parts per million of carbon dioxide in the atmosphere. This increased over time, especially in the second half of the 20th century, to 370 parts per million by the year 2000. Now, I'm not a chemist and I can't completely wrap my mind around this and what that really looks like. But scientists throughout the world overwhelmingly say that this is the cause of the problem. This graph and this table is taken directly from chapter 5 of our textbook, shows the relationship between that increase in CO2 concentration in the global atmosphere and rising global temperatures. So to begin with, the horizontal line in the middle represents the long-term average global temperature. You have to grab a little pen here. So this line here, and it's somewhere just around below 58 degrees, 58 degrees Fahrenheit. So this is an average global temperature. So you're taking into account all different parts of the world. Okay. Now, the bars that are below that average, and those are the bars that are primarily on the left in terms of as you're looking to the screen. These bars indicate temperatures below the average. And then the bars that are above the line show temperatures that are above the average. So, grab that pen again. So here is temperatures that are below the average. And here are temperatures that were kind of above the average. So the idea here is that really since somewhere after 1970, we start to see more and more that the average temperature is increasing by about 1 degree. So the increase is here. So if we look at, 1990 through 2000, I think this goes to 2006 officially. We're looking at these temperatures here, average temperatures about 1 degree Fahrenheit, consistently above the average. And then finally, the black line shows the concentration of carbon dioxide in parts per million. Similar to the previous screen, this thick orange line here, that is similar to this black line here. And you can see in 1880, it was somewhere around 280 parts per million, and then it increases to something like 390 parts per million by 2006, roughly. Oh, excuse those blue lines here. I'll get them added. Let's see. There we go. So the rising temperature, according to the scientists, will have profound effects on our lives in a number of ways. It's going to make it more difficult for some species to survive because it will change the ecosystems of places. Some places will be more susceptible to drought. Some other places will be more susceptible to fires. Other places will therefore be less conducive to having a food supply to support particular habitats in certain ecosystems. So the effects are wide-ranging. Another possible effect is rising sea levels. This figure, taken again from chapter 5, shows possible scenarios of sea level rise. The dark color is a sea level rise of 1 meter or less. And this will affect kind of the edges of the United States, both in the south and the east coast. The more difficult or worse scenario is a sea level rise of up to 6 meters. And this could have dramatic consequences for cities and communities along these areas. And it's going to be very costly to make these places continue to be hospitable and continue to be places where people can live and enjoy a normal quality of life. So we talked about the causes. The main cause is carbon emissions from human activity, and here are some pictures to illustrate that idea. Carbon emissions coming from power plants and factories, and from the use and generation of power by fossil fuels, through automobile emissions. And so that's part of it. We know that that's a cause. This graph here, this again taken from chapter 5, is a very interesting chart, and it helps put into perspective where a lot of the carbon emissions are occurring in the world. The red bar shows the percent of global energy use, and the white bar shows the percent of global population. So let's start on the left and look at the United States. The United States uses 20% of global energy, and I believe this is for fossil fuels. 20%. The United States has just under 5% of the world's population. So you're doing the math here. So if we take population, for example, we know world population is something like just over 7 billion people. And then you can do the math, how many live in the US, how many live in Europe and China and so on, and then you can kind of get a percent. So really the United States doesn't account for a huge amount of the population, especially if we compare it to other places. China, for example, has the greatest share of the world's population at 20%. So the United States has 5% of the world's population. Now we use more energy than the rest of the world as a percentage. So we're at 20%. If you look at Europe, Europe is using about 16% of global energy. Europe has about 6% of the global population. Let's look now at China. And China uses about 17% of global energy use, and has again about 20% of the population. So you can see the numbers here for the percentages here for these other areas, Africa and Latin America. Now, another interesting table from chapter 5 is CO2 emissions per capita. And this word here, this term per capita, is a great one. It's used in a lot of different contexts. Oftentimes we hear about per capita economic growth. We'll hear about the use of some per capita use of some resource. And per capita basically means per person. So you've got to do some math here to get per capita. So if we look at CO2 emissions, and let's start at the left here with the United States. The United States, and this is, I believe, for 2012, The United States produced or emitted just something like 16 to 17 metric tons of CO2 um, per capita. So again, that is per person. So it doesn't mean literally that every person emitted that much CO2. I don't think I emitted that much CO2. Um, Power plants obviously emit a lot more CO2 than I'm responsible for. But if you do the overall math, you kind of count out, okay, if it were, it's a kind of a hypothetical, if we did think of it this way, for every person in the United States, how much CO2 emissions would there be? So it's a little bit it's kind of hard to wrap your mind around sometimes, this idea of per capita. But it does give us an interesting indication of how much CO2 emissions we're generating compared to other countries. And so you can see the same per capita emissions for Asia, Europe, China, Latin America, and Africa. So what are some solutions here? Some of the main solutions are so again, some possible solutions: wind power, solar power, fuel efficiency. And here are some more specific ideas or policies that have been put forward by a lot of environmental advocates as a possible way to reduce carbon emissions. One would be a tax on carbon-based fuels. So the idea here is that if people have to pay more for something, say like gasoline, they'll change their behavior and use less of that and be willing to maybe take public transportation or invest in an electric vehicle or what have you. Excuse me. You could also increase the costs of energy that comes from power plants that are using fossil fuels. There's a whole host of possibilities there with taxes. Another possibility is to direct more public investment in alternative energy sources, solar power and wind and so on. And as we mentioned earlier, the US government today still continues to give or direct more money and resources to the fossil fuel industry in terms of subsidies and so on. Another policy is increasing public funding for research on energy alternatives, and it's similar to kind of what I had just said. Another one is investing more in public transportation systems. We can reduce carbon emissions dramatically if more people take the train and light rail and so on and get out of their cars. Currently, we heavily favor the automobile in our society. And we'll actually talk about this, and I think next week when we're going to talk about the automobile versus public transportation. Another interesting policy that would help us reduce carbon emissions is retrofitting buildings for energy efficiency. Our buildings, commercial buildings in particular, are very inefficient and use a lot of excess energy and resulting in the emission of more carbon. And then finally, one of the obstacles to finding a solution to climate change is corporate power. And corporate power, corporations fund massive lobbying efforts to block possible laws that would lead to a decline in the use of carbon funding campaigns of conservative politicians. So those politicians who are opposed to taking action to reduce carbon emissions receive a lot of money from especially the oil industry and the coal industry and so on. Corporations engage in issue advertising. And so you'll see commercials on TV, for example, supporting conventional energy use. There's this kind of climate change denial out there that's being promoted by those who are opposed to or who do not believe that climate change is taking place. And some conservative think tanks out there have recruited conservative scientists to do research that casts doubt on whether or not global warming is actually taking place. And the best example of this is a very conservative research think tank called Americans for Prosperity. And this think tank is funded by William and David Koch, oil billionaires. David recently passed away, but they are strong climate change deniers and have funded research that continues to cast doubt on the science. Okay, so that's all I have for now. The author expands on a number of these points in the textbook, so it's a really good chapter and really worthwhile spending the time on it. Okay, so see you later. Oops.